Well, it's 1 for the money, 2 for the show, 3 to get ready. Now go, cat, go, but don't you step on my blue suede shoe. You can do anything but lay off of my blue suede shoe. Well, you can knock me down, step in my face, slander my name all over.
Section 7.2 is called General Form of a Quadratic Function. So we better talk about what general form is. But first, let's review the form we've already talked about. We've talked about standard form. Now, standard form is also called vertex form by some people. And the form is like this: y equals a x minus h all squared plus k. Incidentally, some people use p and q instead of h and k, but in our workbook we use h and k. Anyway, an example of that would be something like y equals negative 2 x plus 3 all squared minus 7. The nice thing about standard form, and remember it's also called vertex form, the nice thing about this form is you can very, very easily find the vertex. What is the vertex of this parabola? Well, all you do is you take the opposite of this number here, right? What is the h value in this case? The h value is negative 3. And then you take this number right here, the k value, which is negative 7. So the vertex is at negative 3, negative 7. The a value, of course, tells us that the parabola is facing downwards, like this. And because it's less than negative 1, we know it's a narrow parabola. Okay, that was very, very easy to get the vertex. But what if it wasn't in standard form? What if the equation we had was actually in general form? What's that look like? General form looks like y equals ax squared plus bx plus c. So an example of that would be something like y equals negative 2x squared plus 3x minus 4. You cannot tell the vertex just by looking at this thing. There is something you can do to switch from general form to standard form. It's called completing the square, and we do it in pre-calculus 11, and it gives a lot of kids headaches. But we don't have to do it in foundations. So that's good that we don't have to do that. It saves us some time. But still, we'd like to be able to get the vertex quickly so we can graph this without too much hassle. Luckily, there is a way to do that. Now, before I do that, I just want to point out that this is the a value right here, right? The a value is negative 2, just like the a value here was negative 2. And the a value in this case works exactly the same way. So one thing we do know in this case is that the parabola faces downwards and it's narrow, just like over here, because it has the same a value. But that's the only good news we have here. We can't figure out what the vertex is just by looking at this. Luckily, there's a formula that will help us. And that's what we're going to start with, is by writing down what the formula is. In the other pre-calculus video, I show you how to find the formula, and it's quite complicated, and it requires completing the square. Since you don't know how to complete the square, I can't do that. However, at this point, I'm going to switch over to the pre-calculus 11 video, so it's going to be a brutal cut here. Terrible editing job. I apologize for that, but I'm trying to save myself some time. I'm heading to France tomorrow on a school trip, and I need to get some sleep. It's going to be like 30 hours of travel before I get to sleep again. Yuck. Anyway, here we go, switching over to the other video. Now, where did I write that? I guess I wrote it here. The graph of y equals ax squared plus bx plus c is a parabola with a vertex at the point negative b over 2a. And why don't we switch the second one so it has a common denominator. So this is c over 1. I could multiply top and bottom by 4a, so I'd get 4ac minus b squared all over 4a. You can write it like this if you want, or you can write it like this. I think it might be a little bit simpler. Okay, now that's pretty complicated, but what I really want you to focus on here, because this is the really useful bit right there, is that. That's not too hard to memorize. You will have to memorize this if you want to use it. I find that most kids do like this, so you probably want to memorize this. And this will give you the x value of the vertex. This other part here I'm not going to highlight. This is hard to memorize, and you actually don't need it. I'm going to show you why you don't actually need it. You can use it if you want, but you don't need to. So let's show you why this is so useful. So it says, find the vertex for y equals 2x squared plus 4x minus 5. This is not in standard form. I can't tell the vertex right away. So I could complete the square, but that takes a lot of time. But what I could now do is I could find the x value of the vertex. So I'm going to write down x value of vertex. You don't need to write this down, but just so you're clear what I'm talking about, that's what I'm finding right now. The x value of the vertex equals negative b over 2a. So all I have to do is figure out what's a and b and c in this question. Well, the a value is 2, the b value is 4, and the c value is negative 5. Again, you don't need to write that down, but I'll just do it so you understand what I'm doing here. Alright, let's fill it in. Negative b is 4, so negative 4 over 2 times a, and a is 2. So I get negative 4 over 2 times 2 is 4, which means I get negative 1. Okay, there you go. I know in my vertex that the x value is negative 1. I do not need to complete the square or anything. I know that already. Okay, to get the y value, there's two ways you could get the y value. The one way, which I don't really like, is you could use this, 4ac minus b squared over 4a. So let's try it. I just plug in the same numbers. So 4 times a is 2, c is negative 5, minus b is 4, and we're going to square that all over 4 times a, which is 2. Okay, so that equals 4 times 2 is 8, times negative 5 is negative 40, minus 4 squared is 16, all over 8. So that equals negative 40 take away 16 is negative 56 over 8, so it equals negative 7. There you go. The vertex is equal to negative 1, negative 7. I'm finished. Now, the only problem with that is you have to memorize these. And as I said, I don't think negative b over 2a is too hard to memorize. I think you should try to memorize it. It'll make it a lot faster than completing the square. But you don't need to memorize the second one. Here's why. Once you've found this amount right here, this x value of the vertex, how could you use that value to figure out what the y value is of the vertex? Well, what you could do is you could take this x value and you could plug it in to the x's. And once you've plugged it into the x's here, it will give you a y amount. That'll be the y amount of the vertex. Let's show you that this is actually true. Y equals, so all I'm doing now is rewriting this equation up here, but where it says x, I'm going to write negative 1. So I get 2, and then negative 1 squared, plus 4 times negative 1, take away 5. So y equals negative 1 squared, make sure you do that first. Negative 1 squared is 1, times 2 is 2. Take away 4, because 4 times negative 1 is negative 4. Take away another 5. Y equals 2 take away 4 is negative 2, take away another 5 is negative 7. It worked. We got exactly the same answer as we did over here. So I don't know, you can memorize this rather complicated little formula here, or you can just remember the first one, the negative b over 2a, and then once you get that x value, just plug it into the equation and you'll get the y value. That's the way I like to do it. Okay, one more question and we are done. So we're going to graph this function. Boy, that looks really complicated. One way you could do it is you could complete the square, but let's see if we can use our new expertise to figure this out a little faster. The x value of the vertex is equal to, do you remember what it is? Negative b over 2a. So, again, you don't need to write down what a equals, b equals, c equals. You can just plug them in, but just to make sure you're clear, a value is 1/2. B value, negative 3. C value, 5 over 2. So if we're going to do negative b, that's negative negative 3. Be very careful about that. Two negatives. Negative negative 3 over 2 times a, which is 1/2. Okay, negative negative 3 is positive 3, and 2 times 1/2 is just 1. So you get 3 over 1, or 3. The x value is 3. Right, let's get the y value. Now you could use that, I can't even remember it, what is it, 4ac minus, I have no idea actually, because I never use it. What I do is I plug this 3 into both of these x's here. So I get 1/2, then I have 3 squared, minus 3 times 3, plus 5 over 2. Okay, so I have to do 3 squared first. 3 squared is 9 times 1/2 equals 4.5, or you could use fractions. I think decimals work out pretty nice here actually. So 9 times 1/2 is 4.5, minus 9, 3 times 3 is 9, plus, let's change this into a decimal, 5 over 2 is the same as 2.5. 4.5 take away 9 is negative 4.5, plus 2.5 is negative 2. There you go, there's the y value, negative 2. So my vertex is 3, negative 2. All right, remember we're graphing this, so that's a great point to know. The vertex is 3, negative 2. 1, 2, 3, negative 2, 1, 2. All right, does it face up or down? Well, how do you know? You look at the a value, just like in standard form. Remember in standard form there was an a value? Well, the a value in general form is exactly the same. It tells you the same information. So because this is positive, you know this is going to face up. And because it's between 0 and 1, you know this is going to be a wide parabola. So if you know how to use step pattern, you can use step pattern. It's 1/2. The a value is 1/2. So instead of going over 1 and up 1, you'll go over 1 and up 1/2. And then instead of going over 1 and up 3, you'll go up 1.5. And instead of going over 1 and up 5, you'll go over 2.5. I'm just multiplying all those numbers by half, right? Instead of going up 7, I'll go up 3.5. Half, 1, 2, 3. And instead of going up 9, I'll go 4.5. It'll be just a little bit off the grid. And then by symmetry, I could do this. And you will have your answer. You're done. I imagine that quite a few of you do not want to use step pattern on this, and that's fine. I can quickly show you what you would do in that case. So since our vertex is at 3, negative 2, once you've graphed your vertex, you would probably make a little table of values, and you'd pick some values close to 3. Like maybe 2 and 1 and 0. And actually 0 is a good one. I want to show you that one. So if we plug 2 into all these x's here, I'd get 1/2 and then 2 squared minus 3 times 2 plus 5 over 2, which is 2.5. I'm going to put 2.5 equals. Okay, 2 squared is 4 and half of 4 is 2. Take away 3 times 2 is 6 plus 2.5. 2 take away 6 is negative 4, plus 2.5 is negative 1.5. So we should have a point at 2 and negative 1.5. And we do. There it is right there. So that worked. If you put 1 in there, you get the same sort of thing. I don't know. Do we need to do this? Put 1 in there. 1 squared is still 1 times a half is just a half, 0.5. 3 times 1 is just 3, so minus 3, and then plus 2.5. So 0.5 take away 3 is negative 2.5, plus 2.5 is 0. So there should be a point at 1, 0, and there is. This point here, the 0, remember sometimes I told you that it's useful to find the y-intercepts or x-intercepts. So to get the y-intercept in general form, in this form, you, just the same as in standard form, you put 0 into the x's. Well, if it's in general form, and you put 0 into the x's, what's the only thing that's going to be left? This number right here, the c value. So you're going to be left with 2.5 as your y value, and that's your y-intercept at 2.5. Exactly. So the important thing that I want you to see here is in general form. So again, if you don't know what it is, I'll write it. Y equals ax squared plus bx plus c. The y-intercept is always at c. Does that make sense why? If to find the y-intercept, you put 0 into the x's. If I put a 0 here, this first term's all 0. If I put 0 here, this second term's all 0. And what I'll be left with is c. So in general form, the y-intercept is always at c. That's useful to know. Okay, that's the end of this video. So your main thing you want to memorize for today is negative b over 2a.
Cat.